Let f be a field, then characteristic of f is either 0 or a prime field, a prime number p. Now if characteristic of f is prime number, then for every a belonging to f, p into a is equal to 0. So the proof goes like this. Now we will have to show that characteristic of f is either 0 or prime number p. So if characteristic of f is 0, then we are finished. Okay, there is nothing to prove. So let us assume that characteristic of f is p. Okay, non-zero. We want to show that this p is prime number, right? Now what we know that 1 into 1 it's equal to 1, definitely not equal to 0. So this p cannot be equal to 1, so p is greater than or equal to 2. Okay, we have to show that it is prime number. Now suppose p is composite. If p is composite, let us assume the contrary part of it. So suppose p is composite, then I can write p as equal to k into L. Okay, where k and L are proper factors of p. So 1 less than k less than p, and 1 strictly less than L strictly less than p. Okay, then what we have, p into characteristic of f is equal to p. So p into 1 is equal to 0, right? So p into 1 is equal to 0. This implies that for p I'll substitute k into L. So k into L into 1 is equal to 0. So I can write it as k into 1 into L into 1 is equal to 0. What is f? F is a field and every field is an integral domain. So integral domain has no zero divisors. The product of two elements is 0. So one of them must be equal to 0. So it implies that either k into 1 is equal to 0 or L into 1 is equal to 0. Okay, which is a contradiction. Why contradiction? Because p is a characteristic of f. What by the definition of characteristic, it is the smallest positive integer such that p into 1 is equal to 0. But here I have k less than p, L less than p, and either k into 1 is equal to 0 or L into 1 is equal to 0. So this is the contradiction to this fact here. Okay, so our assumption that p is composite is wrong. So what is p? P must be prime number. Okay. Okay, fine. Now we have to show that if characteristic of f is p, then p into a is equal to 0 for every a belonging to f. So consider a belonging to f. Okay, then I can write for p into a as equal to a plus a. How many times? P times, right? I am adding a p times to get p into a. So I can rewrite this a as equal to a into 1 plus a into 1 and so on plus a into 1 again p times. So distributive property I can use for the field. So a into 1 plus and so on 1, how many times? P times. So this is equal to a into p into 1, right? And what is p into 1? It is 0 because characteristic of f is p here. So it is a into 0, it is equal to 0. So for every a belonging to f, I have p into a is equal to 0.